and try to take this limit, right? What were our limit strategies? I could just plug it in. What would you like to plug in?
0.
All right, so let's plug 0 in. Notice the limit goes away because I'm applying the limit. 1 minus cosine of 0 degrees over 0. What's the cosine of 0 degrees? You positive it's equal to 1? Verify it's equal to 1. What kind of picture are you looking at? Unit circle, good. Do I need a triangle on that? Triangle, yeah, maybe not for 0 degrees, but good idea because we use the triangle a lot. Okay, I get this format. Do you remember what that was called? Can I determine the answer? No, it's called indeterminate, which is really signifying to you to do what? All right, so I need to do more work, exactly. Okay, so I'm not taking derivatives right now. I am trying to apply a limit. What more work did we do? What were some of the strategies we did? If it was a fraction, what did we try to do? Factor, good. Can I factor any of this trig stuff? No? Okay. Okay, that's taking derivatives. We're just trying to apply a limit. Okay, but that is a quotient rule. You're correct. But I'm just trying to find the limit. I'm trying to find a value to this. So I can't factor it. Can I just cancel those h's out and say it's cos? No, you cannot do that. Correct. So you got your book out, trig identities in the front cover. Do you see some identity that looks similar to this? Do you find a trig identity that looks similar? Front cover of your book. Anybody find it? Or in the back. Sorry, is it in the back page? Oh, okay. What did you find it to be? Did you find any of them similar to this? Look around. What did you find it? What's the blue heading? Power reducing. Look at the power reducing. Okay, do you see power reducing? So what does a power reducing say? What's the power reducing say? Come on. Sine squared theta is equal to what? 1 minus cosine, right? 1 minus cosine 2 theta all over 2. That's a power reducing. When you first learned it, we called it the double angle or the half angle because theta and 2 theta were half of each other. All right, so that looks similar. I'm a little off though, aren't I? How am I not quite matching? Let's take a look here. This has the same h as this. What does that tell you about that yellow blob? Should they be, what should be down here for me to have that yellow blob? I'm missing a theta. Can I put a theta down there? Can I just do something like this? Okay, as long as I put one in the top. Agreed? I don't want one in the top because I want it to match this. So if I multiply the right-hand side by 1 over theta, what could I do to the left-hand side? What could I put down here to make a match? So are those okay algebraically? Are they equivalent? If I divide by one, I divide by the other, and I kept them. Would you agree with that? So what does that tell me I can do? Well, I'm going to take this guy right here. That's a 0. And I'm going to rewrite it as what? What can I substitute it as? We're going to have to be a little careful, aren't we? So tell me about that little yellow blob. What is h going to be equivalent to now? What's h going to be equal to? 2 theta. It's the yellow blob. Would you agree with that? Are you okay with that? So now, could I say that the limit as, let's see, what am I going to put down there now? What am I going to put? What do I want it to do? Theta, I want to go to where? Why don't I need a 2 theta? Because what's 2 times 0? All right. And now this idea of 1 minus cosine 2 theta over 2 theta still goes 0 over 0. So I'm going to equate that to taking the limit as theta goes to 0 of its equivalent. So I'm just going to highlight this. So it's equivalent. I don't want that because I know that that blows up on me. Can I replace it with that green? Are those the same thing? What do you think? Are they the same? Yeah. All right. Let's see if that helps me. Let's see if by doing that replacement, that helps me. Plug in 0, and what do you get? You get 1. How do you know you get 1? What's the sine of 0? Sine of 0 is how much? Sine of 0, 0. We okay with that? Okay, sine of 0 is 0. Over 0, I end up with 0 over 0. So what does that tell me I still need to do? More work. Has anybody seen something like this before? I think it was on your last test. Can you say that again? We did that called the sandwich theorem. Oh, I'm missing a theta, aren't I? Or am I missing a sine? Who am I missing? Oh, I hate that when it does that. Sorry. How would that be okay? And why would I rewrite it that way? This is going to turn into what? Turns into 1. And now when I plug in 0, I have 1 times what? Sine of 0, which is 0. You are correct. And I get 0. So that means that this limit is equal to 0. That was a lot of work to show that. And you might say, well, I thought we were doing derivatives. Well, do derivatives have something to do with limits? What's the definition of a derivative? What is that definition of a derivative? The limit as delta x approaches 0 of what? What was that definition? Come on, f of that the definition of a derivative? Oh, by the way, what is the definition of a derivative finding you? Give me all the words you remember. The slope of the tangent at a specific point, sometimes called the instantaneous rate of change. What's the, go ahead. As the distance between P and Q approach 0, that means they're at the same point. Okay, so it's instantaneous rate of change. Do you see a delta y over delta x? I don't see any y's up here. Who's your delta y? The numerator, right? F of x. Okay. You good with that? All right, so I've given you the tools. All right. So let's see if we can use the tools. Here's what I'm asking you to do is find the derivative of the sine of x. Do you know what that is? Do you have any idea what that is? Besides you. So if you don't know what a derivative of that is, what tools do you have that you can at least think about what it might be? No idea at all?
Use that.
Use what? The definition? How would you use that definition? What would we need to write down then? I don't have a shortcut rule for this. All that fun of shortcut rules is now gone. So we're back to this. So the limit as delta x heads towards 0. What am I going to do with the f of x plus delta x? What am I going to get? Sine of the angle minus f of x all over delta x. I just could use my definition. I have no other strategies right now but the definition. So if all else fails, I go back to where I originally started. Can I cancel out those delta x's? Can I can't cancel them out. Can I distribute sine and say that the sine of x plus delta x is the sine of x plus the sine of delta x? Can you? Not sure. What did we say about trig and their angles? Can you mess around with them at all? I think you have the back page of your book open. Do we have a trig identity for the sine of the sum of two angles? Do we have something with that? What do you know? Sum and difference formulas. Can you find them in your back of your book? What's the sum and difference formula say to us that that's equal to? Sine of who? Let's look up here instead of A and B. We could think of this as A and B, if that helps. Sine of A. Cosine of. So I'm going to erase my A. I said A. I meant to write X. Thank you. Cosine of delta X. Keep going. So if I'm adding here, I'm going to be adding here. And then what am I going to get? Cosine of X. Oh, why am I writing A? I know I am, but sine of delta X. And all of this is over delta X. And don't forget to subtract the sine of X, the rest of your numerator. Well, that sure just got busy, didn't it? Can I just plug in 0? I can try. So what do I get when I just plug in 0? Oh, so it didn't work so well, did it? Okay, so what can I do anything with this? Do I have any terms I can combine together or anything even similar to each other? Do I have anything similar to each other? What'd you say? There's 2 sine of x's. Okay, let's see if we can't do something with those. So I'm going to switch up on you a little bit. I'm really tired of writing delta x. So probably from now on, we probably won't be writing delta x anymore. We're going to look at delta x, and we're going to assign it a new letter. I'm really just tired of writing it. So now we're going to start using h's, and that's just not a variable I made up for that. That's just one that we use in calculus to signify delta x. Okay? So if I just change that variable up, is it okay for me to say that h goes to 0? Would you be all right with that? All right. So I'm going to take those 2 yellow things. And Quaid, you said they were in common, right? What do we usually do in algebra? And this is calculus is all algebra. We have not done really any calculus yet. What can I do when I have 2 common things there? Why would I even want to group them together? Like terms. And what would you do with those? If you have one in one term and one in the other, what can you do because they're both? Okay. Notice I changed that to h. And what do I have left? Let's see, cosine of x, sine of h. And I'm going to divide it all by h. Let's see if you have any questions on that. Good morning, Mr. Welts. Oh, I'm so tired. Look at them.
Are you guys tired?
I know.
Friday.
We're doing like the biggest proof of all.
Oh my goodness.
I know.
I don't want proofs.
Oh, they like them.
Algebra.
You don't?
Not proofs.
Oh, they just want the answer. Headed to Bozeman, you need anything?
No, he's coming back.
Okay.
Yeah, snow tires put on.
I know it's supposed to snow this weekend in Butte. Look at them all.
I was ready for Friday on Monday. Yeah. It was this one of those
Really?
weeks, like I was really ready.
Did we have a bad situation yesterday?
Bad situation?
A bad situation yesterday? Let me pause. Here we go. So what am I going to do now? Have you seen something just about like this just a minute ago? Look at your notes. Okay, I'll give you a hint. Do you have something like that on your notes?
Yeah,
Like really close to that something?
sine square.
And would we say that's equal to? What did we say the limit as h, what did we say just earlier? What did we say that limit was equal to? 0. So what do you think everything in blue is equal to? So what's everything in blue times sine? 0, but does that apply the limit to this section of it? So let's apply the limit just to what I have left. And all I have left is this component of it. Cosine of x sine, oh shoot, sine of h all over h. Don't forget, it's still divided by h. Well, do you know what the sine of h over h is as h goes to 0? Did we prove that earlier? Is that equal to 1? So what's 1 times cosine x? I don't have a place to plug in h, so it's just equal to cosine x. So let's think about what we just did there. We said that the derivative with respect to x of sine of x is equal to what? All that proved what? What's the derivative of sine of x? Cosine of x. Can you believe that? Well, if that's true, I was hoping somebody would say, let's look at the graph. That's a graph of who? Sine. All right, let's start looking at slopes. What's the slope? Right at that tip top. And what angle measure is that? So at 90, I'm at 0. And what's the derivative right there at that bottom? And what degree measure is that? I should maybe label this. Let's label this. So that's 100 and, oh, I'm sorry, that's 270, and that's 0. What do you know about the slope right here? Is it positive or negative? Pretty steep or not very? Pretty steep. And it's negative. So that's right here. Pretty negative, steep number. What do you know about the slope right here? Is it the same value as that? But it's not, it's positive. And what's the slope right here? Is it the same as the slope at the end here? Or at the beginning? Yeah. So, oops, it's up here, isn't it? It's a 1. So if I just graph the slope of sine, do I get cosine? All right. So what do you think the derivative of cosine is? Well, we can't just, maybe it's tangent, yeah. Okay, so let's try a couple derivatives here. How do I take the derivative of sine squared x? Is x being squared, sine being squared, or the whole thing? Okay, so here's what I like to do, is rewrite it differently. Remember that square on the word sine is equal to that whole thing squared. Those are equivalent. I like to take the derivative of the red piece because I can see my power. So power down, and what do you get? Power down, 2 sine of x. You dissolve the outside, dissolve the inside. Cosine of x. We just proved the sine of x derivative was cosine of x. Okay, let's try number 2. How are you going to do this one? What's the derivative of sine of 3x? What's the derivative of sine? So cosine of the angle, keep going. Inside, inside. Who's my inside here? It is. And so what's the derivative of 3x? Now I like to write it this way because 3x times 3 is 9x, but that's not part of my answer. It's a coefficient on the front. So now let's combine these 3, or 2, I guess, into a third, and let's rewrite it as the sine of 3x to the power of 3. Those are the equivalent functions. So how would I take the derivative of that? What would I get? So list it all out. What would I get? 3 to the power of what? Keep going. Dissolve the inside. What do you get? Keep going. There's another inside. It's like that M&M with, yeah. So I like to put that 3 out in front and get 9 sine of 3x squared cosine of 3x. Okay. We're going to save these other two for when we get back over the weekend, because I want to try to do cosine, and then you've got just not very much for homework. So if you're trying to do cosine, what are you forced to do on cosine? You don't have a choice. What's the only thing you know how to do now? Okay, good. So here we go. The limit, and I changed it to h of the cosine of x plus h minus the cosine of x all over h. All righty. Well, if I plug in 0, I get cosine of x minus cosine of x is 0. I get 0 over 0. I need to do more work. We tried factoring. We knew that factoring wasn't going to work. Can I distribute cosine? Do you have your book open? What is the sum rule for cosine? I think there should be a minus in there. It's opposite of the sign. And that's just something that worked out. And you might say, where did we get all that? Do you remember proving that last year in math? Yeah, we had to prove them. Okay, so any ideas now?
Factor.
Okay, so who do you want to combine up?
Cosine of x.
Okay, so if I take out the cosine of x, I'm left with cosine of h minus 1 all over h, and I'm left, and I'll get out of your way here in a minute. So if I combine those, I factor out just like we did the last one, and I'm left with a cosine of h minus 1. Don't forget it's minus 1. And then I have this sine of x over h. So do I know something here? Goes equals what? Okay, and 0 times anything is 0. So I'm left with one piece of a limit left, negative the sine of x over h. Is that what I have left? I think I'm missing something. I don't know. I just forgot to write it down. Isn't this what I have left, folks? So don't I still have sine of h here? Thank you. What happens with the sine of h over h? That was a proof that we did earlier that we just used, and now we're going to use again. This equals negative sine of x. So that's its derivative. So if I ask you to take the derivative of the first one on your page there, let me go scroll up. So if I ask you to take the derivative of cosine of negative 2x, what would you tell me its derivative is? What's the derivative of cosine now? Negative sine of the angle. Keep going. Chain rule, yep. Who am I missing? So I like to bring that out in front, and it's going to change everything to be positive. Okay, try the next one. If I was going to do the next one, I would do a rewrite on it. I wouldn't take the derivative as it looks there. I would rewrite it. Say it's cosine of 3x quantity cubed. So take the derivative, and what do you get? Keep going. Careful. Power down. Times. That's a lot. So if I sorted all this out, it looks like it would be negative 9 cosine of 3x quantity squared. Yeah, this negative, which isn't real apparent, is right there. So the derivative of cosine is negative sine. Ugh, what would you have to do in question number 3? Maybe we'll leave that for next time. You would need the product rule. Good. Okay, I'm asking you now to do tangent. Ugh. Do you think you want to use the definition of tangent? Could you? And use all that f of x plus h minus f of x, that? Could you use that? Sure, but is there maybe a slicker, easier way now that we've done 2 other things? So y equals the sine of x. Are these equivalent? Are those two equivalent? Yeah? Okay. So what rule do I need to use now? I don't want to use the definition anymore. What rule do I know now? The quotient rule. How do you take the derivative of the quotient? What do you do? So the derivative of the top times the bottom minus the top times the derivative of the bottom. Notice that negative came in there over. And notice I put the square on it that way. It doesn't matter. What happens when I have these two negatives here? And if I clean this up, I have cosine squared plus sine squared. You've ever heard of that before? What's it equal to? Oh, look how sweet this turns out to be. And what's 1 over cosine squared equal to? What's another name for that? 1 over cosine. What's another name for that? Would you agree with that? So what's your derivative tangent? Okay, so you have homework. And I might even count this as a take-home quiz. I need you to find the derivative secant, cosecant, and cotangent. Do you think you ever want to use your definition of derivatives on it? No. What are you going to want to change these into? What are you going to want to change secant into? What is secant? 1 over cosine. Could you now take the derivative? Okay. This